Good morning, all of you. If my voice is audible. Okay, so most of you are joined. Yeah, so let's continue. Yeah, so today we are going to discuss the third type of notation, which is called theta notation. Okay, so this is a representation of theta. So we will have this more to inside we have it. So this is a representation of theta. Sometimes this is also called best case. Fine. Sometimes for this notation as a best case in terms of time complexity. Okay, so remember Vigo is sometimes called worst case, and omega is sometimes called average case, and theta notation is called your best case. Fine. So I will discuss this thing, why it is called worst case, why it is called average case, why it is called and why it is called and uh, best case. So for time being, remember, omega Vigo notation is also called worst case, omega is called average case, and theta is called best case in terms of when we are calculating the time complexity. ठीक है, जब भी आप टी ऑफ एन को कैलकुलेट करेंगे टाइम कॉम्प्लेक्सिटी, तो ये नोटेशन का रिप्रेजेंट रहेगा। तो विको जो होगा आपका वर्स्ट केस के लिए होगा, ओमेगा जो होगा आपका एवरेज केस के लिए लेंगे, और थीटा जो लेंगे हम लोग बेस्ट केस के लिए। ठीक है, कब लेंगे जब हम लोग टाइम कॉम्प्लेक्सिटी डिस्कस करेंगे। ठीक है, so let us define theta notation. So when I can say, when I can say f of n, yeah, when I can say f of n is theta of g of n, or 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 when I can say f of n is equal to theta of g of n. Fine. So when कब बोल सकते हैं? Now when it is true, now it is true if and if there are two functions such that c1 g1 is less than equal to f of n is less than equal to some constant c2 into g of 2n for all c1 comma c2 are positive constant. Right? For all c1 and c2 are positive constant, and for all n is greater than equal to n0. where again n0 is your positive constant. Yes. Now this condition should be true. Okay. If this condition is true, अगर ये condition आपका true है, that is we have two function g1 and g2. Now I'm having two function here. Now in the previous cases I'm only one function. तो यहाँ पर क्या है, एक फंक्शन होगा g1 जो कि f(n) से छोटा होगा, दूसरा फंक्शन होगा आपका g2 जो कि आपका f(n) से बड़ा होगा. ठीक है. Such that c1 and c2 are some constant which is positive constant. Similarly n0 is positive constant, and for all n greater than n0. Okay. Now if we draw the graph for this one, अगर तो ग्राफ बनाएंगे इसके लिए, I draw the graph. Now suppose this is my graph. Let it be f. And if I'm saying f of n is equal to theta of some g of n. Okay, theta of some g of n. Now it is only possible. Now suppose this is my f of n. Okay. So let me do one. Now this is your some constant to n. Some constant c1 into g1 n. Now this is the point. This point is okay. So from the graph it is clear. Now you can see that now there is two function. One is g2n which is greater than f of 1, and one is g1n which is smaller than f of 1. If this condition is true, okay, if this condition is true, then only what? You can say f of n is equal to theta of n. So this is a mathematical representation. Now this is a mathematical representation. This must be true. Or when it can be true, can anyone say when it can be true? It is only true. A very important point. Again, in other word, I can say f of n is equal to theta of g of n if and only if, okay, if and only if, it is only possible if and only if, when it is possible if and only if f of n is equal to big O on g of n and f of n is equal to omega on g of n. Okay. Now this condition is true, then only it is possible. Because when it is true, then f of n, what happens? Is less than equal to g of n. And when if this is true, what is happened? Now f of n is greater than equal to g of n. Yes or no? Now this condition is true. This condition will be true only when this is true and this is true. Fine. So कहने का मतलब है if f of n is theta of g of n, then f of n should be big of g of n, and f of n should be omega of g of n. Fine. Now you have to remember these 2 points. अगर f of n theta है, okay, f of n equal to theta of g of n, then this two condition must be true. So when these two condition must be true if they have equal value. If they have equal values. That is the reason while we choosing the Bigot notation of upper bound, we are choosing least upper bound. While we are choosing the lower bound, we are choosing max lower bound. Okay? And when both are equal, then we are saying it is a theta notation. Okay. Now we get clear. So if I give some questions, right? Is it clear? So when we can say best case or theta notation, f of n is theta of g of n, if and only if there are existing two functions g1n and g2n such that some constant c1 into g1n should be less than equal to f of n and some constant c2 into g2n it should be greater than equal to f of n. For all c1 and c2 are positive constant and for all n greater than or equal to n0. After n0 this must be true. You must have two functions such that it follows. Okay, or in other terms, we can say if f of n is theta of g of n, it is only possible when f of n is big of g of n and f of n is omega of g of n. If both the conditions are true, then only we can say this is true. Okay. For example, if I give suppose 3n to the power of 5 minus 16n plus 2. Okay. Now I already discussed all the three notations. Now I request all of you to try to answer this question. So as you answer this question, you will get some more idea. So if I say now this is 5, okay, this is 5, 3 and 2.5. Now you have to just answer whether it is true or false. Suppose I write it is equal to order of n to the power of 5. Is it true? Can I write this one?
Yes,
If f
sir.
of n is given this one, can I write this one?
Yes, sir.
Yes, we can
Yes,
write
sir.
this one because as per the rule, okay, as per the rule, this g of n should be greater than or equal to. In this case, it is equal to. Okay, in this case, it is equal to. Now I can say this is equal to somehow this is greater than or equal to what? Highest function can happen to the power of 5. Fine, clear? Now, suppose I write same thing. Suppose I write can I write this one like this? F of n is order of n to the power 17. क्या मिल सकते हैं ऐसे? Is it true or false?
Yes, sir.
Yes,
Yes,
this
sir.
is also true. This is also true because now n to the power 17 is greater than n to the power 5. Correct? Okay, fine. Now can I write it is order of n to the power 2? Can I write
No,
this
sir.
one? No. This
No,
is
sir.
wrong. Why it is wrong? Why it is wrong? Now this is less than f of n. What is the highest function of f of n? F of n का highest function क्या था? n to the power 5. हमने g of n क्या लिया? Square लिया. For any value of n0, it will be not true. इसलिए ये गलत है. Is it clear? Till now it is clear. Now suppose I write, can I write this one? Omega of n to the power of 5. क्या मिल सकते हैं?
Yes, sir.
Yes, again the condition क्योंकि हम लोग condition क्या था? F of n should be greater than or equal to g of n. If we ignore the constant, now in this case क्या हो रहा? It is equal to. Fine. So can I write like this omega of n to the power of 70?
No, sir. No, sir.
Can I write? No, it is wrong. Why? Because in this case g of n, now this condition will not hold. So g of n is greater than. Now this is not true. Fine. Now can I write like this omega of n square
Yes, sir.
Yes, we can write.
Yes, sir.
Because it is small function. Clear? Now, come back to there. Can I write this is theta of, now this function are same for all, okay? सबके लिए same है, 3n to the power of 5 minus 16n plus 2, ठीक है? इसके लिए भी same है, 3n to the power of 5 minus 16n plus 2, ठीक है? सबके लिए same है. Now can I write theta of n square, क्या लिख सकते हैं ये?
No, sir.
No, sir.
No, sir.
Fine, it is not. Can I write theta of n to the power of 17?
No, sir.
Again, this is not true.
No, sir.
Can I write theta of n to the power of 5?
Yes, sir.
Can I write n to the power of 5? Yes, we can
Yes, sir.
write n to the power of 5.
Yes, sir.
Now you can ऑब्जर्वेशन कर सकते हो, बिगो में आपका क्या है, मल्टीपल आंसर आ रहे हैं, है कि नहीं? बिगो में क्या है, n to the power 17 भी ट्रू है, n to the power of अगर मैं 6 लिखता हूँ, that is also true. Yes or no? Yes or no? सिमिलरली ओमेगा में
Yes,
क्या है,
sir.
आपका मल्टीपल आंसर आ रहे हैं, लेकिन थीटा में क्या होगा, एक ही आंसर होगा. Okay, exact answer. What is the exact answer? What is the exact answer? N to the power of 5. When I can say theta, when this is true, देखो ये भी true है और इसके लिए भी true है. When theta of, when f of n is theta of g of n, yeah, when it is true, when it should be order of, when it is f of n is big of g of n, and f of n is omega of g of n. Now you can see from this example, when it is possible, when n equal to 5, when n equal to 5. इसलिए हम थीटा का वैल्यू क्या है, n equal to 5. और एग्जैक्ट वैल्यू कब ट्रू होगा, वो हमेशा एग्जैक्ट वैल्यू में ही वो ट्रू होगा, ये याद रखना. एग्जैक्ट वैल्यू, इसलिए हम लोग जो भी फंक्शन लिए थे एफ ऑफ एन, इसलिए हम लोग जब भी हम लोग चूज कर रहे थे लोअर बाउंड्री, ठीक है, इसलिए हम लोग क्या किए, लोअर बाउंड्री हमेशा क्लोजेस्ट टू एफ ऑफ एन, क्लोजेस्ट टू एफ ऑफ एन. ऐसा इसमें सिमिलरली अपर बाउंड्री जब चूज किया हम लोग, सॉरी इसमें अपर बाउंड्री जब चूज किए क्लोजेस्ट टू एफ ऑफ एन, सिमिलरली लोअर बाउंड्री चूज करते हैं भी क्लोजेस्ट टू एफ ऑफ एन. नाउ थीटा विल गिव यू द एग्जैक्ट आंसर. थीटा क्या देगा आपका थीटा क्या देगा, हमेशा एग्जैक्ट वैल्यू देगा, याद रखना. कभी भी आपको एक्यूरेट वैल्यू चाहिए, एक्यूरेट वैल्यू. नाउ इन दिस केस यू मे गेट एक्यूरेट वैल्यू, मे नॉट, ठीक है, दिस केस may or may not, because multiple answer आएगा, but whenever you take theta you always get accurate value, because for only one condition only this will be true. If my point is clear, is it clear?
Yes, sir. Yes, sir.
Case of, now till now we are not talking about time complexity, okay, हम लोग टाइम कॉम्प्लेक्सिटी बात नहीं कर रहे. अगर आप बिगो का नोटेशन चूज कर रहे हो तो मल्टीपल वैल्यू आएगा, लेकिन हम लोगों ने क्या डिसाइड किया, जब भी हम चूज करेंगे क्लोजेस्ट टू है, सिमिलरली यहाँ पर भी क्लोजेस्ट टू है, लेकिन यहाँ पर जब भी आप थीटा को निकालोगे वैल्यू, थीटा का वैल्यू एक ही आएगा जो एक्यूरेट आएगा. कब आएगा, जब दोनों कंडीशन, ये वाला भी ट्रू होगा और ये वाला भी ट्रू होगा, वो उसका एग्जैक्ट आंसर होगा. फाइन, clear?
Yes, sir.
Now this is about
Yes,
notation. What is big O notation, what is omega notation, and what is theta notation. Now now the
Sir.
next question is, yes,
So in the last class, you has given us a question that for same f of n, we have to find different g of n for big O notation and big omega
theta
notation.
notation. So आया उसका आंसर?
No, sir, I didn't find.
Yeah, क्योंकि there will be only when you find the theta notation, इसके जब भी आप कोई भी फंक्शन लोगे f of n, ठीक है, okay, f of n, now you will get a multiple answer for big O and omega. big O and omega के लिए multiple answer रहेंगे, ठीक है, लेकिन जब आप थीटा निकालोगे उसका एक ही आंसर रहेगा, जो आपको क्या रहेगा, एक्यूरेट आंसर, ठीक है, एग्जैक्ट आंसर बोलते हैं ना, एग्जैक्ट आंसर अज्यूम क्या कहते हैं, while choosing the big O You have to choose the smallest f of n. है कि नहीं? While choosing the omega, you have to choose the largest f of n. है कि नहीं?
Yes, sir.
The reason behind that is so that we can achieve to the closest. कितना closest आ सके f of n का, कितना closest आ सके. ठीक है, तो वो
Yes.
कभी भी f of n, कोई भी f of n आप ऐसा नहीं लिख सकते हो जिसका ये डिफरेंट होगा और ये भी डिफरेंट होगा. ठीक है, ऐसा
Yes, sir.
what is the reason? Because we have some function called theta and we always try to reach closest to it. Always try to reach closest to it. ठीक है, so exact answer क्या आएगा? थीटा will be kept. पर इतना रखना है, थीटा हमेशा आपको एग्जैक्ट आंसर देगा और एक ही ऑप्शन रहेगा वहाँ पर. लेकिन बिगो और ओमेगा में क्या होगा, आपका मल्टीपल आंसर आएंगे. लेकिन यहाँ पर हम लोग एज्यूम कर रहे हैं while choosing it I have to choose the lowest one and while choosing it I have to choose the highest one. What is the reason? Reason is because I have to reach closest to the theta. Fine. Clear? Is it clear? Clear? Yes or no?
Yes, sir.
Okay. Now
Sir.
we will discuss how this can be related to the time complexity. जब जो नोटेशन हम लोग ने सीखा है उसको यूज करके टाइम कॉम्प्लेक्सिटी कैसे निकालेंगे. ठीक है, तो उससे पहले एक छोटा सा प्रॉपर्टीज याद रखना है जब आप कैलकुलेट करोगे. एक एडिशन प्रॉपर्टी, देयर आर मेनी प्रॉपर्टीज आई एम नॉट डिस्कसिंग. ठीक है, it will be discussed in algorithm again when you study the design of algorithm, we will detail you study. So there are two property you have to remember for the time being data structure. One is called addition property. What is addition property? If f1n is equal to big O g1n, ठीक है, and f2n is equal to big O g2n. Okay, then what will be the f of n, f1n plus, suppose I'm adding these two function f2n. Fine. Then what will be the big O of these two function? Can anyone say? बस समझ में आया क्या बोल रहे हैं हम?
N plus G2N.
Okay, if f1 if given if f of n is big of g of n and f2n is big of g2n, then suppose I'm adding these two function f1n plus f2n, then it will be big of g of n plus g2 of n. And how to find this one? Now इन दोनों में जो larger function होगा, ठीक है, suppose in this case g1n is greater function than g2n, then the final will be this big O of g of n. I've already discussed. Suppose I want to find, I'm given the question, suppose n square plus log n. Okay, suppose I find the big O of this one. So what is the big O of this one? It will be order of what? It will be
N square.
n square,
N
bigger,
square.
bigger function.
R square.
Okay, but why? Because out of these two, I have to choose a bigger function. Same case. When you are performing the addition operator, two functions are there. Now you have to choose the bigger one. Which is the big, जो bigger होगा वो उसका answer होगा. Clear this point? Is it clear this point? If there is more
Yes,
than
sir.
two functions,
Yes, sir.
you have to choose the bigger one. That's the property. This is the first property. Addition property बोलते हैं. If f of 1 is order of g of 1, f of 2n is order of g of n2. When I add these two function, now it will be order of these two function, and final answer will be दोनों में से जो larger function होगा. ठीक है? Similarly, second property is called multiplication property. Okay, multiplication property. So what the multiplication properties say? Same if f of 1. Same again if f of 1 is order of 0 1 and f of 2 order of 0 1, so I can write f of 1 star f of 2n. Now it will be order of for example, if I give it like n into log n, okay, or you take n square into log n. Okay, now suppose I give it, find the order of this one. So what is the order of this one? What will the order of this one? Yes, what will be the big of this function? Now यहाँ पर भी दो फंक्शन है, देखो एक आपका n स्क्वायर है, एक आपका log n है. यहाँ पर सिंपल आप जस्ट मल्टीप्लाई कीजिए दोनों फंक्शन को, इट विल बी n स्क्वायर log n. So what is the big of this one? It will be n square log n. ठीक है, यहाँ पर सिंपली मल्टीप्लाई करना है और उसका जो मल्टीप्लिकेशन के बाद जो भी फंक्शन आएगा दोनों का, इट विल बी ऑर्डर ऑफ g1n dot g2n. Clear? But in case of addition, what you have to choose? What you have to choose? The function which is taking larger value or function with a higher greatest value. But in this case, you have to multiply. So if these 2 points are clear, yes.
Yes, sir.
Yes,
Addition,
sir.
while addition, you have to choose the larger function. By multiplication, just multiply both the function. Okay. When I multiply n square and log n, it will be n square log n. The final answer will be it is order of n square log n. Clear? So now these two properties we will going to use while calculating the time complexity. Okay? Okay? So
Yes, sir.
if you want to write down, just note down. If you want to note down something, I'm giving 2 minutes time. Yes, I'm giving 2 minutes time to you. Just note down what you just write down this example. It's a very good example to differentiate between big O, omega and theta. हो गया? Okay, so let's move on. So what is the time complexity? How we define? What is time complexity? Can anyone define me the definition of time complexity? Yes. Yes. Anyone define me? Yes. नहीं आता है किसी को?
So to run any function, the time taken by it,
Run
the time taken by an algorithm to run that function.
or you can say the time taken by algorithm to run the function. Okay, any other answer? So how much time it will take? The question is. So time complexity basically denoted by Tn. It is simply we can define the time taken by the algorithm to give us the output. Okay, yes or no? Suppose there is a problem, I written an algorithm. Suppose there is a problem P, I written some solution in terms of algorithm. Now I will check how much time that the algorithm will take to give us the output. Yes, is the thing? है कि नहीं? यही चीज है ना?
Yes, sir.
एक प्रॉब्लम है, उसका एक सोल्यूशन लिखे जिसको हम एल्गोरिथम बोले. अब इस एल्गोरिथम को मैं एग्जीक्यूट करूंगा. ठीक है, एग्जीक्यूट करने से क्या आएगा? आउटपुट आएगा. अब मेरे को चेक करना है इस आउटपुट को आने के लिए उसको कितना टाइम लगा. Okay, so let me discuss. Before discussing time complexity, I will discuss simple example. ठीक है, अरे है मेरे पास, ध्यान से सुनना, कुछ मैं एक्सप्लेन करना चाहता हूँ. ठीक है, आपको अरे साइज हमने दिया यहाँ पर 5, एन इक्वल टू क्या लिया आपने, 5 लिया. अरे का साइज क्या है, 5. और आपको क्या करना है अभी, आपको क्या करना है अभी, सॉर्ट करना है देखो. फाइन. नाउ सपोज द एलिमेंट्स आर 1 2 3 4 5. Clear? My points are clear. I am given an array of size 5. Now elements of array are 1 2 3 4 5. Now you have to sort this element. Now first case I am given case number 1. Okay. Now input elements are given 4. Again you have to sort the element from छोटे से बड़ा. Okay. 4 5 3 2 and 1. Okay. Now I am giving another case. Same array size 5. Same elements 1 2 3 4 5, but now I slightly change the order, like 2 4 1 3 and 5. Now case number 3, case number 3. Now I give the same array of size 5. Now elements are 1 2 3 4 5. Clear? Now what is the problem statement? Problem statement is I'm given an array of size n. Now given the input values. Okay. Now you have to choose a sorting algorithm. ठीक है, for all these 3 cases same sorting algorithm and sort it. ठीक है, sort करना है. अब मुझे बताओ in which case it will take less amount of time and in which case it will take large amount of time or more amount of time. किस केस में, 3 केस है, केस 1, केस 2 एंड केस 3. किस केस में ज्यादा टाइम लेगा और किस केस में कम टाइम लेगा. यस, और apply insertion sort. All of you know the insertion sort. Insertion sort पता है सबको. Apply insertion sort concept here. Now tell me in which case, case 1, case 2, case 3 में, in which case it will take more amount of time and in which case it will take less amount of time.
Case 1 में more amount of time और case 3 में
it
less.
will take more amount of time and case 3 will take less amount of time. Why? Because this is already sorted. Yes or no? If you see the element, this is already sorted. And if you see this element, this is all the elements are reversely placed. Okay, now what we have to do? I have to place 5 here, now 4 here. Now it is completely ulta place here. So it will take less. Now this will say some elements are sorted, some are not sorted. In this, इसमें क्या है? All the elements are in their proper position. इसमें क्या है? All the elements are in a reverse order. But in this case, some elements are there proper position, some are not proper position. ठीक है? तो यहाँ पर एक चीज याद रखना, while calculating time complexity, so which case I have to take, which case sorting जब करेंगे, किसका time complexity लेना हमें हमेशा. Now this is my best case, this is my best case, and this is my worst case. How I decided? Now this is depend upon your input given, in which order I am giving the input. Yes or no? अगर input हमने दिया 1 2 3 4 5, ठीक है ना, size is fixed. Now your time complexity depend upon 2 things. Okay, first thing size. Size मतलब n का size कितना है. Now same question. Suppose n equal to 5 के लिए जितना टाइम लगेगा, क्या n equal to 1000 के लिए कितना टाइम लगेगा? Answer is No. Yes or no? For sorting the 5 element, it will take less amount of time sorting 1000 element. है कि नहीं? Yes or no? Clear? अगर हम लोग 5 एलिमेंट को सॉर्ट कर रहे हैं और 1000 एलिमेंट को सॉर्ट कर रहे हैं, दोनों का टाइम कॉम्प्लेक्सिटी अलग होगा. तो जब भी टाइम कॉम्प्लेक्सिटी आप कैलकुलेट करोगे, नाउ डिपेंड अपॉन n number of elements. Now first number of elements are same. If number of elements are same, which is n, ठीक है. Now second thing is depend upon how the input is given, how I am providing the input. Now अगर input आपका ऐसे देंगे अगर 1 2 3 4 5, so what is happening here? Now input is already sorted, so it is my best case. I have no need to perform any more swapping to sort the element. So it is my best case. So further I does not require any swapping. Swapping का time बच जाएगा. Now this is my best case. But input is in reverse order. The number of swapping क्या होगा यहाँ पर? Increase. Again you need some time to swap the element. Okay? Again you need some time to swap the element. So this is my worst case. Fine. The first point, while calculating the T of n, what you have to measure now is depend upon size of the element. Okay, number of element or size of the array or size of the matrix. Okay. Second thing, how the input is given, how we are providing the input, how we are providing the input. Okay. Now my question is, so while calculating the time complexity, now algorithm for all these three will be same or different. अगर मैं algorithm लिखूंगा तीनों के लिए सेम रहेगा या अलग रहेगा? यस. अगर हम सॉर्टिंग एल्गोरिथम लिखेंगे तीनों के लिए, सेम रहेगा अलग रहेगा? इट विल बी सेम. यस और नो? ओनली व्हाट विल डिफरेंट? योर इनपुट. जो जहां पर हम इनपुट देंगे वही डिफरेंट रहेगा, बाकी सब प्रोसेस क्या रहेगा? सेम रहेगा. है कि नहीं? जितना भी प्रोसेस है आपका एल्गोरिथम का वो सेम रहेगा. ओनली डिफरेंस क्या होगा? आपका इनपुट पे डिफरेंट होगा. ठीक है. तो आप मुझे बताइए, जब आप टाइम कॉम्प्लेक्सिटी कैलकुलेट करोगे तो कौन सा एल्गोरिथम को लेना बेस्ट, कौन सा सिचुएशन में लेना बेस्ट होगा? So now this, now you have to always take the worst case. Worst case means that is मतलब इस if this algorithm के लिए, ठीक है, worst case क्या है? Now this is the worst case. This is the worst case, or worst case input. That means it will never going to take more amount than its worst case. इससे ज्यादा वो कभी भी टाइम ज्यादा नहीं लेगा, क्योंकि ये हम लोग का इनपुट का सबसे वर्स्ट केस है कि नहीं? वर्स्ट केस है मतलब सब एलिमेंट रिवर्स ऑर्डर में है कि नहीं? सब एलिमेंट रिवर्स ऑर्डर में है, तो ये वर्स्ट केस है. तो मैं बोल सकता हूँ अगर किसी भी एल्गोरिथम का हम लोग वर्स्ट केस लेंगे, ठीक है, तो आई कैन मेक श्योर दैट इट विल नेवर गोइंग टू टेक द मच, उससे ज्यादा टाइम वो कभी भी नहीं लेगा. उसके वर्स्ट केस से टाइम कभी भी ज्यादा वो नहीं लेगा. इसलिए हम लोग जब भी टाइम कॉम्प्लेक्सिटी कैलकुलेट करेंगे हमेशा इन टर्म्स ऑफ क्या करेंगे? बिगो में कैलकुलेट करेंगे. तो बताया था बिगो क्या था आपका? बिगो इज योर वर्स्ट केस. समझना? बिगो इज योर वर्स्ट केस. वी ऑलवेज कैलकुलेट टाइम कॉम्प्लेक्सिटी इन बिगो. व्हाई इज वर्स्ट केस कैलकुलेट करेंगे? बिकॉज once I calculate the worst case, it is sure that it will never going to take much amount of time than the worst case. इसलिए जब भी हम लोग वर्स्ट केस, अगर जब भी वर्स्ट केस चूज करते थे हम लोग क्लोजेस्ट टू लोएस्ट वर्स्ट केस चूज करते थे. वी आर नॉट गोइंग टू चूज, सपोज n to power 5 है, वी आर नॉट गोइंग टू चूज 17 n to power 17. no doubt is true, but we are always choose to closest to n to power of 5. ऐसा ना, इसलिए हम लोग लोअर वर्स्ट केस चूज करते हैं, लोअर अपर बाउंड्री. Clear? Now this point is clear. So whenever you calculate the time complexity Tn, we always go for the worst case. You worst case जाएंगे. Once I calculate the worst case, I have to make sure that it will never going to take more amount of time than the worst case. But some cases I also calculate. Suppose if I even calculate best case, now best case will be your theta. Okay, best case will be your theta because this will be your exact